So we've been talking about the Kalam cosmological argument. If you have your handout, you can look and see where we've come so far in this argument. So we've discussed the first premise, which is if the universe began to exist, then the universe has a cause of its beginning. That was premise one. Yes. Yeah, I have extra copies of the handouts here. I'll just give you one of each. So the first one is the outline, the overall outline of every argument, but the second handout is the Kalam cosmological argument. I'm going to close the door real quick.
I'm totally wrong with it. And,
that's why I need to borrow a marker.
Okay. Do you need a handout as well? Okay. All right. There you go. All right. And so the first class that we did on the Kalam cosmological argument, we looked at the first premise. And if you want, you can go back and listen on YouTube to that class. And then what we did the last 2 weeks was we looked at two separate philosophical arguments for the second premise in defense of the proposition that the universe began to exist. And so last time we saw that the impossibility of forming an actually infinite collection of things by adding one member at a time implies that the universe began to exist, which is the second premise of the argument. And so we can summarize the argument from last time as follows. And it's on the handout. You can look at it there as well. A collection formed by successive addition cannot be actually infinite. That's premise one. A collection formed by successive addition, adding one member at a time, cannot be actually infinite. Premise two, the temporal series of events is a collection formed by successive addition. We don't have any new handouts. This is what we've been talking about. Beautiful. So the temporal series of events is a collection formed by successive addition. And all that means is that the past events, so if we think about it from now, if the universe is eternal, then the past events, the number of past events is infinite, right? If the universe is eternal, the past events. And that this collection of events has been formed through successive addition, one event at a time, sort of like dominoes falling over. And so therefore, premise three, the temporal series of events cannot be actually infinite. And that just follows logically, deductively from the premises of the argument. And so now we have basically two separate, independent philosophical arguments for the second premise of the Kalam cosmological argument. One based upon the impossibility of the existence of an actually infinite number of things. That was the first philosophical argument. And then secondly, based upon the impossibility of forming an actually infinite collection of things by adding one member at a time. And so before we lose the forest for the trees, so to speak, let's step back for a moment and ask really what we've done here with these two arguments. What we've basically argued is that the idea of an infinite past is absurd. That's basically what we've argued. The past cannot be infinite, and therefore it must have a beginning. And so these arguments, though seemingly complex at the surface level and mind-stretching, can be very simply shared. And that is important that we understand it, lest we just throw up our hands and say, well, this stuff is just too complicated for us. And so the first argument, based on the impossibility of forming an actually infinite number of things, what we can say about this very simply is that the existence of an actually infinite number of things is impossible because of the absurdities that would result if it could exist. And so, for example, what is infinity minus infinity? That's a question that we could ask. It's a very, very simple question. What is infinity minus infinity? And you can't just do that. You can't do that in mathematics. It's basically forbidden. And that's because you get self-contradictory answers. Whenever you subtract infinity minus infinity, you can get any number from 0 to infinity. And so you get self-contradictory answers, and that shows that infinity is just an idea in our minds. It's not something that can exist in reality. That is a very, very simple statement of the first argument. Okay, so the idea of an actually infinite number of things is absurd. And then the second argument that we talked about, you can give a very simple illustration of this one, of an infinite series of dominoes, and say, well, how can the present domino ever fall if an infinite number of earlier dominoes had to fall one after another? You'd never actually get to the present domino. We know that the past can't be infinite. It must have had a beginning. It must be finite. Okay, so that's a basic way that you can share the second philosophical defense, is to think about a series of dominoes falling. And so there you see that we shared those two arguments in less than a minute, basically. right? And so these arguments can be shared very simply. The first one, again, is just ask the question, what is infinity minus infinity? You get contradictory answers. That shows that the concept of infinity is absurd. It's just something in our mind. It can't exist in reality. And then the second one is that we think of this illustration of a series of dominoes falling one after another. How could the present domino ever be reached? If an infinite number of dominoes had to fall first, we can never reach the present domino, because before we get to that domino, another domino had to fall back to infinity. We can go back and back and back, and we can never reach the present domino. And so now what we want to do is move on to the scientific confirmations of the beginning of the universe. And so in one of the most astonishing developments of modern astronomy and astrophysics, which our Muslim friend Al-Ghazali could never have anticipated. Al-Ghazali was the 12th century Muslim theologian that sort of brought this argument together. And it was back in the 12th century. He came up with these philosophical arguments back in the 12th century. You often hear that the Dark Ages were just this time of, complete ignorance and all this stuff, but these arguments were formed back then in the 12th century. But so Al-Ghazali could never have guessed that we were going to have such strong scientific confirmation for the beginning of the universe. And so first things first, I like to think of these scientific confirmations as strong evidence for the beginning of the universe, but as sort of confirmations of what we've already learned from the philosophical arguments. Okay, so the scientific evidence sort of confirms for us the truth of the philosophical arguments. They are a confirmation of a conclusion already reached. And so that's to say, given the scientific evidence, the statement the universe began to exist is more probable than it would have been without that evidence. And so the evidence confirms the truth of that premise, that the universe began to exist. And so if someone says to you, as they often do, well, no one really knows if the universe began to exist. Nobody knows whether the universe had a beginning or is eternal. And what they're usually thinking of here when they say no is no with certainty. Okay, they're usually saying we don't know with certainty that the universe began to exist. But of course, no one is claiming that. In these arguments, we're not claiming that we know now with certainty that the universe began to exist. That's not what we're claiming. What we're saying is that given the scientific evidence, given the philosophical arguments, it is more probable than not that the universe did have a beginning. That's what we're saying. And that can't be refuted by just saying, well, we don't know. We don't have certainty on the issue. That's not something that we're interested in here. And so at least it seems to me almost undeniable to say that the scientific evidence favors the beginning of the universe, that the universe began to exist. That statement is more probable given the scientific evidence that we have today than it would have been without it. And so the evidence at least confirms the second premise, even if it doesn't render it certain. Okay, I just want to make sure that we're all on the same page here. Certainty is a will-o'-the-wisp, and we don't need to be concerned about it. And so the question is the premise more probable than not, given the evidence that we have? That's the question. Is the statement more probable than not, given the evidence that we have? And I think that it is. All right, and so let's move on to the first scientific confirmation, which comes from the expansion of the universe, from the expansion of the universe. And so all throughout history, men have always assumed that the universe as a whole is unchanging. Of course, things in the universe are always moving, planets and people and cars and everything. Things in the universe are moving, but the universe as a whole, people have assumed, humans have assumed, is unchanging. The universe just sort of exists there. And this was also Albert Einstein's assumption when he first began work on his so-called general theory of relativity. And so in 1917, we're going to go have a little history lesson here. 1917, Einstein applied his gravitational theory, which is called the general theory of relativity. And it's not really a theory of relativity. It's a theory of gravitation, his general theory of relativity. So it's a theory of gravitation. And it's the theory that is accepted in physics today. And so in 1917, Einstein began to apply his newly discovered gravitational theory to the universe as a whole. Okay, so he wanted to apply it to the whole universe. But he found that something was terribly amiss. Okay, so his equations from his theory described a universe which was either blowing up like a balloon, or else it was collapsing back in on itself. That's what his calculations would have led him to. And so during the 1920s, the Russian mathematician Alexander Friedman And the Belgian astronomer Georges Lemaitre, I don't know if I can write those down here. So Friedman, write his name, Friedman, and then Lemaitre, and this is a French guy, or no, Belgian, sorry. And so these two guys worked, and they took his theory of relativity, his general theory of relativity at face value. And so what they discovered independently, they discovered models of the universe which were expanding. Okay, and so these guys basically took Einstein's theory of relativity, applied it to the universe, and independently came up with models of the universe where the universe was expanding. Okay, and so in 1929, the American astronomer Edwin Hubble, through tireless observations at Mount Wilson Observatory, confirmed Friedman and Lemaitre's model, their theories. He found that the light coming from us, from distant galaxies, appears to be redder than expected. Okay, so what he found was he basically looked at the stars in the sky and he found that they were redder than he would have expected. Okay, and so this red shift in the light was most plausibly explained by the galaxies moving away from us. And so therefore the light waves, the wavelengths are stretched so that they appear to be redder than expected. And so wherever Hubble trained his telescope in the night sky, he observed this so-called red shift in the stars. Okay, it appeared that we were at the center of a cosmic explosion. That's what it looked like through the telescope. And so that all of these other galaxies around us are flying away from us at tremendous speeds. So let me just talk a little bit more about the Doppler effect that we saw here. And so I actually have a degree in audio production. And what we did, we talked about the Doppler effect. It happens in sound waves as well. And so when you say that you're sitting on the street over here and an ambulance whizzes by, okay, and we've all heard this, maybe it's a fire truck, but it starts to go by, it sounds woo, 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 and then once it gets past you, the sound waves gets deeper, right? It gets lower. So woo, 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 once it passes you up. That's what's called the Doppler effect. Okay, so this ambulance is going away from us. When it's coming toward us, the sound waves get compressed because the ambulance is moving toward us. But then when it goes past us, the sound waves, since the car is moving, they get stretched out. And so the waves sound lower to us, even though the ambulance is playing the same note. It's not like it's changing its note right when it gets to you, right? And so the sound waves, what's happening is the sound waves, when it's driving toward you, are being compressed, which makes the sound higher pitched. And when it moves away from you, the sound waves get stretched out, and it sounds like it's lower pitched. That's the basic, what's called the Doppler effect. And so it can apply to sound waves. It can also apply to light waves. And so that's what Hubble was observing with the stars, is that these stars, these planets, are moving away from us. Okay, and so the light waves are being stretched out. Okay, so they look red. They look a little bit redder than we would expect. And so that's very good confirmation that these galaxies and everything, all these stars and everything in the universe is moving away from us. Okay, so, but now, according to this model that these two guys came up with, we're not really at the center of the universe, okay, in this model. Really, an observer in any galaxy, no matter where you are, is going to look out and see this red shift. Okay, and this is because, according to the theory, it's really space itself that's expanding. The galaxies are at rest, actually, but it's space itself that's expanding. So they recede away from each other as space itself expands. And so the best way to visualize this, I think, is to imagine a balloon. And I've done my best to draw this little deflated balloon here on the board. And so we imagine that this is sort of the beginning of the universe. So it was deflated. And so let's imagine that we have buttons glued onto the surface of the balloon here when it's deflated. Okay, so as you blow up the balloon, the buttons become further and further apart. Even though the buttons, with respect to the surface of the balloon, they're not moving at all, right? But since the balloon itself is expanding, the buttons are growing further and further apart from each other. Okay, so that's sort of the visualization that we can have in our mind of what is happening when we say that space itself is expanding. And so the Friedman-Lemaitre model, or theory, eventually came to be known as, and you probably have heard this before, the Big Bang Theory. Okay, but that name can be very misleading. Okay, the Big Bang sounds like it's an explosion, right? It sounds like it's just this big old explosion in empty space. But thinking of the expansion of the universe as a sort of explosion could mislead us into thinking that the galaxies are moving out. That what happened is all these galaxies are moving out into pre-existing space, right? But that would be a complete misunderstanding of the theory. And so as we've seen, this theory is much more radical. It's space itself. Space itself is expanding. And so as you trace that expansion back in time, and that's where this little drawing comes into play. So as you trace this expansion back in time, the galaxies will get closer and closer together. So as we go back in time, since space, if we go back in time, space is getting smaller and smaller. Eventually, the distance between any 2 points is going to become 0 on this model. Okay, and so obviously we can't get any closer than 0, right? But so at that point, we've reached the boundary of space and time. And so space and time cannot be extended any further than that. And this is literally the beginning of the universe. Okay? And so to imagine this is the model that we're going to be using here. So we imagine that our three-dimensional space can be sort of like a disk. Okay? So as you go back in time, space shrinks down until the distance between any 2 points becomes 0 here. And that's the beginning of the universe. And so this vertical dimension represents time here. And so we can represent the expansion of space geometrically as a cone, like this, okay? So this is sort of where we are now, where we have all this space and everything, all the space between the galaxies. But as we go back in time, since it's space that is expanding, right? So as we go back in time, space gets smaller and smaller and smaller back eventually to 0, okay? And so what's interesting about the geometry of a cone is that although it can be extended indefinitely in one direction, it can go forever in this direction, it can't go indefinitely in the other direction, right? And so it's got to come to a point or to a boundary. And so because this direction represents time and the boundary point lies in the past, that point represents the beginning of the universe. So it implies that the past is finite, and therefore time and space and the universe began to exist. Okay, and since space-time is the arena in which all matter and energy exist, the beginning of space and time is literally the beginning of all the matter and energy in the universe. And so it's the beginning of the universe itself. And so notice that there's simply nothing on the other side of this boundary point here. There's nothing on the other side of it. There's nothing prior to the beginning of the universe. And here it's important to not be misled by words. And this is something that we covered in a previous class. When scientists say there is nothing prior to the initial boundary, they do not mean that there is something prior to it and that is a state of nothingness. That is not what they mean. That would be to treat nothing as though it were something. Okay, and remember when we talked about what the word nothing means for those of us that were in class. So nothing is a term of universal negation. It means not anything. That's what nothing means. And so when they say that there is nothing prior to the Big Bang or nothing prior to the boundary point here, what they mean is that there is not anything prior to the boundary point. There is not anything prior to it. And so at that boundary, it is false that there is something prior to this point. And so incredibly, the standard Big Bang model thus predicts an absolute beginning of the universe. And so if this model is correct, then we have amazing scientific confirmation of the second premise of the Kalam cosmological argument that the universe began to exist. And so let's go ahead and open it up for discussion. If there's any questions about the stuff that we've covered today, and I'll just give a little bit of a caveat here. I am obviously not a cosmologist, okay, and so I'm not going to be able to answer every question. But I have done a little bit of a study on this, and so if there's any questions that you have pertaining this theory, then it's definitely open to it. Does everyone understand how the expansion of the universe serves as good evidence that the universe began to exist? Right? So if the universe is expanding, then as we go back in time, it's sort of compressing. Right? It's getting smaller and smaller. The distance between objects eventually becomes 0. That's how they have come up with this figure of 13.7 billion years old, or however old that they say the universe is based on this model. Is that once they trace the universe back and back and back and back, they eventually reach this point here where we can't go further any further in the past. Okay, and so that's why this model that was come up independently with these by these two separate guys, this model is now very, very good evidence that the universe began to exist.
Can you go over a couple of basic definitions, like what is a universe, what is a galaxy? Like, go over like exactly what those words are.
Okay, so the universe would be all contiguous space-time reality. And so that's basically all physical reality, all energy, all matter, space and time.
We're in. You're going, it's the whole thing.
The whole thing, yeah, all of space and time.
All right.
And that's what the universe is that it's basically the set of everything, all the physical reality. Okay? And so what a galaxy is sort of a cluster of stars. And so we have our solar system, but we're part of the Milky Way galaxy. And so the Milky Way galaxy is basically a collection of stars. And the galaxies form they look like different shapes. So like we have these like spiral arms sort of that come out of our galaxy, and it looks like a little milky, like if you were to stir a little milky cup or something like that. And so that's sort of why it was termed the Milky Way. And we can actually see those. I think we're in one of the arms. And that's why when you go out and you look, you'll see this like big strip of stars in the middle of the sky. And that's actually the Milky Way, is that we're in this galaxy. But as you look further and further and further into the distance, you start to see other galaxies that are basically the same thing. It's a collection of billions and billions of stars, and that they're contained in these little galaxies. We're actually on a collision course with Andromeda, the Andromeda galaxy. And I think about 2 billion years or something like that in the future, the Andromeda galaxy and the Milky Way galaxy are going to collide. And they're going to, like all the stars and everything in those galaxies are going to get all jumbled up and mixed up and stuff. And so that's an interesting, prediction that is bound to happen, basically, unless Jesus comes back before then. So,
He does? 2 billion years?
yeah, and that's, 2 billion years, yeah.
So when people...
Let me, real quick, does that answer your questions?
Yes.
Okay.
So when people look at the stars, they say you're looking into the past. So how would that play into this argument? Where does that make sense?
So we are looking into the past. And the reason why we're looking into the past is because light can only travel so fast. And so that's why what we are looking at is the so-called observable universe. So anything beyond that, beyond the furthest star, light just hasn't had time to sort of reach us. And so we can only see what has basically, what light has been able to reach us. Okay, and so even though we are looking into the past, that I don't think really has any implications for the model that we've been discussing on the expansion of the universe. So it's just an interesting sort of point, is that we're looking into the past when we look into the sky. So I wouldn't think that there's anything further than that would have implications for the argument.
Could you explain? You said it closed in, and I'm confused about
this guy here?
Yeah.
This model here? Okay, so this is basically a model, and this is just to help us sort of visualize, right, what's happening. Is that we can visualize, this is time, so time is the vertical dimension here. So as we go back in time, space, and this is the x-axis here. This is the x-axis. As we go back in time, space is shrinking down. Okay? And so that's because the universe is expanding. The space itself is expanding. Okay? But as we go back in time, since it's expanding, as we go...
Can I dump here?
Yeah, go ahead. Go ahead.
Do this. Space.
Right, so space is coming down to a point here. Okay, and so as we go forward in time, right, as we go up in time, the space is expanding or continually growing. That's why when we look up into the stars, we see this red shift. It's that these galaxies are moving away from each other. and that's observational evidence of this model. And so space itself is expanding. So as we go back in time, as we reverse, we look into the past, space is shrinking down, right? And eventually the distance between any 2 points becomes 0. Okay, and that marks the beginning of the universe. You can't go less than 0, right? You can't have negative space between two things, right? You can only go as far down as 0. And so that's the implication here, is that with this model, it implies the beginning of the universe. Okay. Does that help? Does that make sense? Okay. Good morning.
So what's the other side of the argument on folks that do believe that there is not a beginning?
So,
what are they saying
in response to this?
to this
right.
effect?
Okay, so what they would say is that, and this is another thing where I'm just going to give a caveat that I'm not super well informed on this, and so what I'll do is do my best to try to explain sort of what they do. And so there are other models of the universe that try to account for the expansion of the universe. But these models have sort of, and this is what William Lane Craig says, is that these models that are being offered to sort of restore the eternality of the universe, all of these models are failing. Okay, so there are certain models like oscillation models, which basically say that the universe is going through contracting and expanding phases indefinitely. So it contracts, then it expands, then it contracts, then it expands. But there are problems with all of these models, and I don't want to get really into all that. What you can do, actually, there's a book called Blackwell Companion to Natural Theology, and this is probably the absolute most advanced technical book on natural theology. And what William Lane Craig does, he actually is joined by cosmologist William Sinclair, and he writes this article where they look painstakingly at every model. Any viable model that was being offered to restore the eternality of the past. And so they provide arguments for why these models fail, for why they are not widely held among cosmologists. And so if you want to look deeper, like really deep, then you can look into this book, is the Blackwell Companion to Natural Theology. If you want to sort of just get an overview, there's another book that I can recommend. It's called Reasonable Faith. And that's another book written by William Lane Craig. And there he just sort of goes through the general arguments. He doesn't go painstakingly into detail as if to convince a cosmologist, but just to sort of give the rough and ready outline of why these models are not really viable, why they don't restore the eternality of the past. So Reasonable Faith, and then if you want a deeper look into it, then you can go to the Blackwell Companion to Natural Theology.
So people who don't believe that there was a cause, they possibly believe that there was contracting and contracting.
So the oscillation model is just one model that has been offered.
There's several.
And so there's other models that have been offered. And so what happens is that once we go back in time, there's basically the Einstein's general theory of relativity breaks down at some point, and it breaks down. Because at the quantum level, once we get to the subatomic level with quantum particles and that kind of thing, his theory of relativity, his general theory of relativity breaks down. It doesn't apply there. And so we need a quantum theory of gravity, which has yet to be discovered. And so some will say, well, once we get to this time in the past, there's no telling if the universe is eternal at that point, whether the universe comes out on the other side or anything like that. And so that's another option that atheists will sometime, or cosmologists will sometimes offer. And now that one has another horde of serious problems. And I don't believe that one is very widely held either. But so all of these theories are basically just theories to try to restore the eternality of the past, to avoid the prediction made by the standard model. And this is the standard model, is that the universe, with the expansion of the universe, it implies a beginning. And so what some people say is that it breaks down at that point, once we get to the Planck scale, which is the subatomic level where the theory of gravity that Einstein had, where these two guys were trying to apply it to. Once we get to that subatomic level, then his theory breaks down, it doesn't apply, and so we can't really make any predictions. That's what these people claim. And so obviously William Lane Craig covers that objection. I didn't want to cover that in class just because it's getting a little bit too technical. I think we could go there, but it's just a little like that's actually what we were going to discuss next class. If you want to, we can keep that on the schedule. I was just going to remove it so that we could go on to the next confirmation, the next scientific confirmation.
And two, if you can quickly, some of us may not have been here, but if the universe has a cause,
Right.
you reviewed that in the past, but some of us may be wondering why you're trying to figure out that there is a beginning versus it's always been there. So I don't know if you want to just quickly say why.
Okay.
If it has a cause, then that means something must have caused it. Like if you just do
Right.
that quick review, so they know why you've been doing all
Why
this
this
stuff.
is all important.
Yeah, so you can kind of like bring it back home.
Right.
For those
Bring it back home.
who were not in that class before.
Okay. So the overall argument of the Kalam cosmological argument is to show that the beginning of the universe implies that basically God exists. Okay, so how does it do that? The first premise is if the universe
And
began
there are some people that believe that it doesn't. That
What?
there wasn't a beginning.
Yeah, and so what people will do is they will try to reject the second premise. But even the cosmologist Lawrence Krauss that you have heard,
Yeah.
he doesn't deny premise 2. He says that, yeah, probably the universe began to exist as a cosmologist. He's an atheist. Okay, and so there's another guy, Alexander Vilenkin. He's probably one of the most prominent cosmologists alive today. He's an agnostic. He doesn't believe that God exists. Yet he doesn't reject premise 2 of the argument. What he rejects is premise 1. And again, if we go back to premise 1 of the argument, that's if the universe began to exist, then there is a cause at the beginning of the universe. The universe has a cause of its beginning. That's premise 1. And so that's where someone like Alexander Vilenkin, I'll write his name up here. We were going to Lincoln, something like that. It might be an E here. Something like that. You'll find it. Alexander Vilenkin. William Lane Craig and Alexander Vilenkin have actually corresponded on this because Craig pulls from Vilenkin's work. Okay. And there's actually a theorem that he and two other cosmologists formulated called the Borde-Guth-Vilenkin theorem. And what that shows is that any universe that is on average expanding must have had a beginning. And that's a theorem that they proved in 2003 called the Borde-Guth-Vilenkin theorem. And so for that reason, Vilenkin is confident that the universe had a beginning. So anyways, so he rejects premise 1. He rejects that the universe, if the universe began to exist, then the universe has a cause of its existence. And so some atheists will want to reject that premise. They'll want to say that some things can come into being uncaused out of nothing, which is, as we've seen in defense of premise 1, that's just completely absurd. It's worse than magic. It literally is worse than magic. So when you have magic, you at least have the guy pulling a rabbit out of a hat, right? You have the magician and you have the hat. Okay, but if the universe just popped into being uncaused out of nothing for no reason at all, that's literally worse than magic. It just pops into being for no reason. You have no magician. You have no supreme being like God who is omnipotent, able to do these sorts of things. You have nothing like that. And so literally it's worse than magic if you want to deny premise 1. And so we looked at the some defenses of that. What we can also say is that it becomes inexplicable why only universes. Why is it that only universes can come into being uncaused out of nothing? Why can't root beer and Beethoven and bicycles come into being out of nothing? Why is it only universes that come into being out of nothing? And so that's another defense of premise 1. But so the conclusion of the argument is that therefore the universe has a cause, okay, of its beginning. And that doesn't seem like it's too, like, how does that actually pose a problem for the atheist? And we're going to discuss that in depth in a couple weeks. But if you look on your handout, there's a list of attributes that we can pull deductively from the third premise of the argument. And that's premise 4 is that if the universe has a cause, it is an uncaused, beginningless, changeless, immaterial, timeless, spaceless, unimaginably powerful, and personal being that brought the universe into being. That is the cause of the universe. And that's premise 4 of the argument. And these properties of being uncaused, beginningless, changeless, immaterial, timeless, spaceless, unimaginably powerful, and personal, these are basic deductions of what we can draw from the argument. And so what we see is that the cause of the universe must have these properties. And so therefore, if the universe has a cause, then this cause exists, and therefore God exists. That's the basic gist of the argument. And we're going to go into a lot more in depth into that premise when we get there. Right now we're looking at the scientific confirmation of premise 2.
So I'm just curious,
Yes.
what do they then think is the cause of the universe coming into existence? What are those causes?
So some will try to say that there's a cause, but it's impersonal. It's not a personal cause. It's some other sort of natural cause. But there it becomes difficult to sort of explain exactly what that is. And then there's arguments for this cause being personal. And I don't want to get into those arguments right now. But so that's one option that they would want to say, is that the cause, there's a cause, but it's sort of an eternal, timeless, natural cause of some sort, which has a lot of issues. But that's one response. The other response is just to deny that the universe has a cause altogether, so that the universe just came into being. And then the other option is, of course, to try to establish that the universe was eternal and therefore it didn't need a cause. It's just been around forever. It's just been here. And as we saw in the first argument, or really the second argument that we covered, the Leibnizian cosmological argument, or the argument from contingency, we saw that even if the universe is eternal, that doesn't remove the need for an explanation of the universe. Okay, so for instance, think about an eternal lending of geometry books. One person is eternally lending a geometry book from this person to this person to this person to this person. We could still ask, why is this eternal lending of books happening in the first place? You know, it seems perfectly possible that this lending of books could never have, taken place. Or why is it a geometry book and not a physics book? So we can ask these sorts of questions. Even if the universe is eternal, we can still ask, why is the universe eternal rather than having a beginning? Why does a universe at all exist? Why does an eternal universe exist? And so these are still questions that we want to ask and that would still require an explanation. Since the universe is a contingent being, it is not a necessary being. It doesn't exist in all possible worlds. It's a contingent being. It relies on something else for its existence. So, any other questions or comments on this scientific confirmation of the second premise of the argument? Or did that answer your questions? Okay. All right, so for those of us that were at the meeting last night, we had about 8 to 10 people. It was a really good little meeting that we had. It was really interesting. We had some lively dialogue at points here and there. We also ate some good pastries that were delicious, even though they didn't want to sell us any. But it was a really good time, and I'm going to look into possibly going to another conference when another apologetics conference is happening. I'm going to make sure that we're all on board for that as well, so that we can go to another one of those. If we have any other questions, then we'll go ahead and close out a little bit early today. All right, so let's go ahead and go to the Lord in prayer. God, we thank you for another opportunity to come together and to discuss these arguments for your existence. And we thank you again that these arguments are sort of pliable. We can look at these arguments, we can reject them. We don't need to accept these arguments. We thank you for constructing the world in such a way that we can come to these arguments freely and to evaluate the evidence. And if we think these are good arguments, we can accept them. If not, then we are free to reject them. We thank you for setting up the world in such a way. And again, we thank you for the fellowship that we had last night at our meetup. It was awesome. I really appreciate being able to do this. I know that people around the world are not always able to do this sort of thing. And so we thank you again for this opportunity. We pray that we, as we go out in this week, we will be light among the world, in the world. And so we thank you, when we do encounter people, that you will give us the words to speak, that you will bring remembrance to our minds, things that we've discussed in class, things that we've read in Scripture, things that we've read in articles and in books. And so we thank you for this in the name of Jesus. Amen.